Okay, welcome everybody. Thanks so much for coming to this session. So just a few logistics before we get started. So you're going to have a Q&A session right in the end after the talk. So please reserve any questions for the end. If you like something, applause also. Kind of keep it to the end. And the mic is going to be on this side of the room. So please make your way there. Okay, great. So this is day 2 of the conference. Thanks so much all for coming. So quick thought exercise before we begin. What's the most frustrating experience you've had when you visit a website or use an app or any other sort of application? Most likely many of you are going to say that it's slow, it's being unresponsive, yada yada. Also, I'm going to state the bleedingly obvious here. These days with so many different types of platforms, mobile devices, web applications, mobile apps, smart TVs, etc. The end users are being inundated with a lot of sources of information, and as a result, they have very little time. So when they grace your app or your application with their time, you want to really serve them well. You want to do it as fast as possible. So this session is not going to be about building responsive apps, but we'll talk about one tool that you can use in order to build highly responsive apps, and that tool is server-side caching. So the lineup for today. So my name is Umar Zaki. I'm a product manager of Amazon ElastiCache. So I'm going to get started. I'll talk about what caching is, what are the different types of caches, what is Amazon ElastiCache, that's the web service that does caching, and what are some of the use cases, design patterns, and then after that I'll hand it over to Nick, and Nick is from GRE, and he'll talk about what amazing things they have done with ElastiCache, and finally we'll have James, who will also talk about how they have built very responsive apps with ElastiCache. So, what is a cache? So a cache is nothing but a specialized data store that keeps frequently accessed items in memory. And I mentioned caches can help to build highly responsive web apps. So pretty much because the information is in memory, it is very fast to access. So any data store that allows you to do so is a cache. So why use a cache? So I saw this quote on a blog post, latency is the mother of all interactivity, and that's true. As the latency profile of an app or an application goes up, users are likely going to move away from the app. So that's a bad thing. Similarly, as your, let's say a website gets very popular, you start getting lots of users, or if a small part of an app is really hot, some page is really hot, it's likely to increase the latency for all the other users. So that's also a bad thing. And what happens is that a lot of those requests go and hit the database tier, and depending upon how you've architected your entire stack, that database may just tilt and just fall over. So that's again a really bad situation, which will result in horrible end user experience. So with that situation as well, a cache can actually help a lot. And the good thing is, why does the cache work? Primarily because most of the data that you're accessing is primarily reads. And writes are really a small fraction of it. So if you can read it, you better cache it. So let's say you decide, okay, I need to now put a cache on my application stack. You're going to likely encounter a lot of choices. So a tech stack obviously is fairly complex. So let's say you walk through the sort of request coming from, say, a mobile phone. It's going to go all the way into the cloud, and let's say from then it's going to go hit many servers. So there are several sources of latencies that are going to come all along the way. Similarly, depending upon how the app is architected, there could be various aggregation layers that will consolidate requests coming from millions of devices. And let's say one of those layers is getting a lot of requests. Again, that layer could become slow. So there are caches that are there for each of these different tiers. Now we're not going to go into all of it. Instead, we're just going to focus on the server-side caching that's inside the AWS cloud and which is network attached. Then there are many other characteristics of caches as well. So for instance, some caches have persistence, they have different scalability characteristics, some caches are able to warm themselves, etc. So I'm just mentioning them just to give you a sense for the gamut of choices that you're likely going to encounter and the considerations you have to take into account. And then even from the architecture standpoint, you could have a side cache, read-through, write-back, etc. I want to focus on two common caching engines that are there. One is Memcache and Redis. And both of these are open source. And they are both key value, network attached. They're very popular in web architectures. And these are the two that, and that's the reason we have them in our managed service. So let's talk about Memcache first. So this is a fairly simple key value store, in-memory key value store. It's been around for well over a decade now. And many of the top sites and applications, apps, they all use them. Let's just look at the architecture of this. So what you have over here is the cache on the right-hand side. And then you have the application on the left. So the application talks to the cache server using a application client. And this, again, goes over TCP. And I mentioned to you that this is also a clustered cache. So the way clustering is achieved for Memcache is by the client. So client uses a consistent hashing algorithm. And using that algorithm, you actually spread the load across all the different cache servers. Also, I mentioned this is a side cache. So what that means is, what your application does is that it will first look at the cache for information. If the information is there, it's going to return it to the end user. If the information is not there and that's a cache miss, you're going to go to the database or the backend layer. You'll get that information out, put it in the cache, return it back to the application, to the end user, sorry. And it's called a side cache because you have to add one more sort of data path in order to go to the cache. Talk about Redis. Again, this is also a key value store, network attached cache again. It is in memory. It's different from Memcache in the sense that it has support for data structures that makes it really versatile. You've got strings, lists, sets, sorted sets. It supports asynchronous replication out of the box, so you are able to create a read replica, both for HA as well as for read scaling. It supports soft persistence. And I say it's soft because there are some limitations. So if you're going to rely on Redis, let's say, as your primary data store, you better be darn sure about what are the characteristics of how the persistence actually works. And lastly, I should mention that it also has pub/sub capability. So if you want to communicate between different processes or applications, you can use the publisher-subscriber feature of Redis in order to do so. In terms of architecture, fairly similar to that of Memcache, again, network-attached cache. The one thing I want to point out over here is on the right-hand side, you can see that I have added a node for the read replica. So you send a request, a write request to the master. Asynchronously, it will be sent off to the read replica, and that way, both of them are in sync. So that brings me to ElastiCache. So we talked about some popular caching engines. Now let's talk about the managed service that we have at Amazon. So it's ElastiCache. It's like other managed services. It is scalable and secure, but more importantly, it allows you to provision your cache nodes. It allows you to monitor them and take any repair action that you have to do if a node were to fail. It has it's pay as you go, and let's look at sort of how you will structure your application here. Right on top, you have your end users. They're interacting with your web application. That's right below, which is part of a EC2 security group. And there you have your application stack, which consists of the client library. So you use the client library to talk to the cache, and the cache is going to be remote. So you'll go over a TCP hop to actually get to the cache. And the caches are in a cache security group. The reason we do that is to make sure that your caches are secure. So you're able to control explicit access and actually indicate which EC2 machines are able to access your cache. Memcache by default runs wide open, so we don't like that. And that's the reason we added these sort of containers around both your EC2 machines as well as your cache. You also have CloudWatch metrics, similar to other managed services, which allow you to keep tabs on how your cache is doing, what the eviction rate is, etc. Here I show the Memcache protocol that the client is talking, that is from the application to the cache, but the structure is very similar to for Redis as well. So where all is Amazon ElastiCache used? So we have customers using it in all different use cases. And I'm just going to speak to a couple. So on the gaming side, ElastiCache is heavily used to keep track of what all is going on in a game. So you have the transient data for the game that is stored in ElastiCache, what the gamers are doing, what their scores are, what is their behavior, etc. And then you may also conduct some statistics on the user base. All that is also stored in ElastiCache. On the mobile side, you need to be able to handle large number of end users. A lot of those requests are coming into a centralized infrastructure in the cloud. And again, you don't want all of that to be hitting your database or your backend storage layer. And there again, ElastiCache is very helpful. Last thing I want to point out is ad tech. Here what you have generally is large number of requests coming into a very small amount of data. A lot of that information is keeping track of transactions at pretty fine-grained level. As you know, real-time bidding does very, very fine-grained access per impression. So all that information can be kept in a, you have the counters, all that is kept in a cache like ElastiCache. So simple gaming deployment here, just to give you a sense for how ElastiCache interacts with other AWS services. So what you have are the user requests coming in from the left. Typically, it hits Elastic Load Balancer, goes into your front-end application servers that are in a auto-scaling group. So depending upon the load, they sort of grow or shrink. And then you have the in-memory layer, which is typically ElastiCache, in which you are keeping track of, as I mentioned, things like scores, things like what the users are doing. So common design pattern here is like a leaderboard. And then that information is persisted in a back-end relational database, such as MySQL, and then you have CloudFront for the more heavy images and things like that, or other multimedia types of videos, etc. So in terms of design patterns, again, lots of them. We're going to touch upon a few. The most common one is database offloading. So that's something I've been sort of talking about. With a cache, a centralized cache like either Memcache or Redis, you have the ability to grow the centralized cache layer depending upon your need. Let's say that you want to expect a large amount of traffic because let's say you launched your app, or you have launched some major new feature. So then you can provision a much larger layer, and a lot of information there is going to be read-only. So all that can hit in your cache and does not kind of flow all the way down to your database. So that's really the most common use of a cache. Session management come often. We talked about in terms of gaming. Anytime you're keeping track of what your users are doing as part of that interaction with your app or application, that's a session. It happens in gaming, it happens in e-commerce, you have the shopping cart. So again, a cache is used quite heavily over there. Lastly, you have the in-memory sort of storage for time-consuming tasks. So let's say you had a bunch of EMR jobs you had to run to get some really, extract some information from your geo data. And you don't want to be doing this stuff on the fly every time. So you do it sort of once, and then you keep the information in the cache, and then depending upon when your users need them, you can serve them. There are a few more. I'm going to omit those. We have another session on caching tomorrow, a deep dive. It's at 11:30 tomorrow, I believe, DAT207, and we'll go into each of those. So that brings me to the end of my part. And now I'm going to introduce Nick, who's going to tell us about what exciting things they're doing at GRE.
Thanks, Omer. Thanks, everyone. So my name is Nick. I work at GRE. Not many, I don't know if you've heard of GRE before. This is a little bit about our history. GRE was founded in Japan in 2004, first as a social network. And then the company quickly pivoted when mobile really started to become big in Japan, quickly pivoted to mobile games. In 2011, GREE decided to expand and established offices in the US. We have our offices in San Francisco. And at the time, we were using kind of the traditional physical data center model. We had to plan ahead for procurement of systems, configuration of those systems. We had a lot of ITIL background. And we started to see the benefits of moving more towards a DevOps environment. In 2012, GREE acquired a company called Funzio. And this is where AWS came into the picture. And we're very excited about that acquisition. And we were able to really bring the provisioning times to a much more quickly to what we were able to see today. For some time, we had both games inside data centers and also within Amazon. We spent the last year really consolidating everything within Amazon. In fact, just last week, we converted another game out of our data center into Amazon. So what do? We make games. They're all mobile, all free to play. You may recognize some. All for iOS and Android devices currently, and we're also focusing on tablets as well. These are some of our game types. We have about 5. There are 4 here, but we have a couple other game engines as well that kind of run the gamut from the different types of games that people like to play. So our role-playing games, these are our oldest, top-grossing titles, multi-million-dollar franchises, games like Crime City, Modern War, Kingdom Age. These games are consistently in the top charts in iTunes and also in Google Store. We've also started developing games in some other genres. Our hardcore games are more for people that come from the hardcore PC gaming that like to have a much longer play session, more mechanics, a lot more PvP, player versus player action. We've also gotten into real-time strategy. So we just recently announced a Call to Arms. This is a kind of a fast action. You build a small town, you create armies and units, and you send them out, and they go attack other players. And then we also have a very successful casino and casual games franchise, Jackpot Slots, Jackpot Bingo here, and then we have a variety of other games as well, some card battler games and so forth. It's a little bit of a scale of what we're managing today. We have quite a bit within Amazon, as you can see here. A lot of the, as Omer mentioned, a lot of what we do within Amazon is in memory caching. So we have quite a large ElastiCache environment. Our databases as well. A lot of the games have multiple shards to handle all the different data sets. And our application servers generate about a terabyte of data per day. And this is data that's not only data like game events and so forth, but also information about how the health of the game is functioning. And so we use that data to then set our checks, our alerts, and things like that. And as I mentioned earlier, millions of monthly active users. So I want to kind of run through our typical game architecture. This is our oldest architecture, where we really make a heavy use of ElastiCache. This is our role-playing games architecture. Fairly standard if you've worked in a kind of LAMP stack environment. Application servers behind elastic load balancers here. And again, these are PHP-based app servers. All those game events I mentioned, those app servers not only have the actual application itself, but then they send analytics data to our analytics subsystems. Below that, we have our ElastiCache. And this is where, in our games, we make very, very heavy use of ElastiCache. I'll talk more about that in a minute. And then we have our batch processing servers. So these is a tier that we had to insert between our database and cache tier so that we could not overload our databases. And I'll talk a little bit about what we're doing there. And then finally, we use RDS, heavy users of RDS. And we actually developed, we were some of the early users of RDS, so we kind of helped Amazon with their feature set and also we've developed our own way to not have an RDS failover event have an impact with game players. So we've developed this little failover database that when we have an RDS failover, writes will go to that failover database, and when the RDS master comes back, we'll dump all those writes back into the master. So a little bit about caching. The RPG Plus game architecture actually predates what we considered stable NoSQL. But we wanted to have that performance. And back then, there wasn't too much available to us, but we had Memcache and we had databases. So we actually we have our internal response time is actually a lot lower now. We're at closer to 300. We picked a model where Memcache is the authoritative source of data. We still, of course, have RDS on the back end to ensure that we minimize any potential data loss since nodes do disappear. And what it also allowed us to do is to have a much simpler database layer. Since all the kind of heavy lifting, the reading and writing is happening in Memcache, we don't have to have big iron database servers below that. One of the key things that we do there is we don't do any relative row replacements on the databases. So we're always, things like current row value plus 1, we just don't do, because we actually use ElastiCache combined with RDS to kind of sort of do a NoSQL type setup where we're storing very simple data sets within RDS. So here's the data flow. All the reads just hit, they go app server to cache. We have our two types of writes, our synchronous versus asynchronous writes. So for synchronous writes, these are things like when someone's going through a quest and they're going through each step. At the final step, we want to award them an item. We'll want to record that final step directly to the database and then read that back and say, yep, you get an item. So those are kind of the synchronous writes. One thing we never do here is we never do just a blind write. We never just say, hey, we're just going to write this value from the client directly to the database. We always read that, whatever the value is in Memcache first. We see if that makes sense, and then if it's the latest value, we'll then write that. On our asynchronous writes, this is where our batch processor comes in. And our batch processor, we've written that in Node.js, and we're starting to move a lot of that over to Go. And what that does is because 80% of our write traffic is asynchronous, we can send a whole bunch of stuff to this batch processor and say, hey, write this at the next 30-second flush. And so these are the types of situations where, you're doing these quests, and you'll do several quests. You'll get 10 items within that time period. So the app server will send all that stuff downstream. The cache server will, again, send that downstream to the database, but we intercept that at the batch processor. And because we version every single request, the batch processor will then write just the final value to the database with the updated count. And so that really saves a lot of work from our databases. They don't get overloaded. So again, as Omer mentioned, the hashing for Memcache is done at the application level. And in our case, we really use the database more like a key value store, right? We just have a key. We have that version string I was talking about. We have the timestamp. And then we have usually a JSON blob of some data set. What happens, occasionally we do get version collisions. You have one app server sending something, you have another sending something with the same version string. It's usually pretty rare. In that case, our application will fail for most requests, but it happens so quickly, and for some very key requests, we actually have some retries there. But again, the version collisions actually end up being fairly rare, even for some of the more active games where we have hundreds of thousands of people playing a day. So then we get into high concurrency. And so these are things like matchmaking, big battles between large groups of players. In this particular example, this is our world domination events in Modern War. And you create armies, so you can band together a bunch of other players. And then these armies will fight each other, attack each other. So this puts a lot of strain on the whole data layer itself, and there's quite a lot of concurrency happening there. So here we actually do contradict ourselves a little bit. We do relatives update only at the Memcache layer. And so sometimes we do get collisions there where we're trying to just update something very quickly. And in that case, we have a retry cycle. We have it, it's up to 5 times. And usually, because we're using Memcache, it's all in memory, it's very fast. Usually the second, third try, it succeeds. And this actually, I was talking to the engineer that wrote this, and this happens so fast in the code. It's a block of code about this big. And so that's, we usually don't get too many problems, even in the high concurrency events by depending on Memcache. So it's the cloud. It's elastic. Things do fail. We do have Memcache nodes that fail on occasion. And so what happens here is, because our application is, we're sharding across many different Memcache nodes, particular node fails, we'll then send writes directly to the database. So for the time it takes for Memcache or ElastiCache to spin a new node up, put it in play, and get it so that our app servers can talk to it, we'll have a little bit higher load on our databases. But because we're sharding, the impact is only going to affect a certain number of players that are on those database shards. So we'll have a little bit of spike in performance, but usually the node comes back online fairly quickly. At that point, the application notices that the node's back online, starts sending traffic to it, the cache will refill organically, and then we see a drop in database load. So why ElastiCache for us? So compared to EC2, it's actually pretty stable. We don't have as many instances of node failures. Then again, we have a lot more EC2 nodes, so the percentage-wise, ElastiCache is a much more stable platform. The automatic node replacement is great. Same node name, same DNS. We don't have to change anything in the application. When it comes back online, our app sees it, and we send traffic to it. If you're really needing to push very high performance into ElastiCache, the larger instances do have much better network performance. So it really depends on your application if that's something that you need for an individual node. And then recently, I believe it was this year, Amazon announced the configuration endpoint for ElastiCache. And so this is a way for your application to dynamically query or to query the ElastiCache cluster to get information about how many nodes are available. And what this does is you can then have the application use that information with your scaling scripts and so forth to then create new nodes and automatically rebalance your hashes across those nodes. We used to have to do a lot of what we call our manual Memcache migrations, where if we needed to rebalance a node cluster, we would actually spin up a whole new node with the new number of a new cluster with a new number of nodes, and then kind of write to both for some time and then make the switch over. With this configuration endpoint, we can just make the application do that on the fly, and it'll rebalance itself across new nodes that are added to the cluster. We actually just got one of our games to start using that a couple weeks ago, so we're in the watching phase and running a whole bunch of tests to see how that goes. If everything goes well, we'll probably be moving all of our games to make use of the configuration endpoint. So what I've been speaking about so far are kind of our older games. And at the time it made sense, again, because of the nature of NoSQL, it made sense for doing things the way I've just described. But it's kind of it's an old way of doing it. And our newer games, games like War of Nations, CTA, Call to Arms, they're much more modern in terms of architecture. Those games are also focusing on providing a more real-time-like experience for players, to being able to chat with someone in real time and then coordinate how are you going to attack a particular base or something like that. That's going to change our caching model a little bit. We'll probably actually end up having less pools but larger pools of cache, and especially with the configuration endpoint, we can grow and shrink those pools a lot more dynamically. I mentioned our batch processor servers that were built in NoSQL. We've actually moved a lot of that to Go. Go is the Google, a language developed by Google for really good at high concurrency types of applications. So it was a perfect kind of shoe-in for our batch servers. And we have actually had some good success moving a lot of our MySQL batching over to Go. We've been using queuing systems for a while. We've used RabbitMQ, ZeroMQ. Lately, we've been using NSQ as well. So our Call to Arms games can use a lot more queuing for that. And for a long time, we were using the old Memcache libraries. When we initially needed to develop this the architecture for the games, we had some initial problems with Memcache-D. And so we stuck with the Memcache library. So we're finally now coming into the future by using Memcache-D libraries. And that will enable us to make use of the configuration endpoint that Amazon provides with their ElastiCache. So what else? We're really excited after the move to Memcache-D, we can actually make use of CheckSet Tokens. These are within, it's a standard Memcache-D option. It's basically an internal versioning. So we'll probably be able to reduce the number of retries, reduce the incidence of collisions by really making use of the atomic nature of each of those transactions. We will also looking at maybe doing a real NoSQL implementation, right? DynamoDB has come to maturity, so we'll be looking at that. And then Redis as well. We actually do quite a bit of Redis internally right now with some other shared subsystems that our games use. And with the release of the Redis service from Amazon, we actually helped to provide some beta feedback for that, and we're starting to move some of the discrete Redis boxes that we had in our environment into the Amazon Redis service. So we'll see how that goes. That's all I had today. Thanks, and we'll have questions at the end.
Thanks, Nick. So now we're going to hear from James, who is the CTO and co-founder of 2U.
Hi guys, I'm James Koenigsberg and I'm a part of the founding team and CTO at 2U. So what is it that we do? 2U partners with top universities to create great online degrees. And the reason, there's obviously a lot of disruption in our market, but the reason we are different is because we provide real degrees. There's no E, there's no I. When people graduate, they read list alphabetically of people on campus and online. We provide real-life classes, so there's a lot of synchronous learning. You spend about 12 to 16 hours a week in a live class, face-to-face. It's real faculty. It's faculty from great universities, which I will mention in a minute. And we provide real outcomes, which I will bring up at the end and share some of the outcomes that we've been seeing lately. Here's some of our partners we partner with. As an example, Georgetown University, which is a 250-year-old school, brand that's older than Coke, that trusted us to partner with them and sort of help to unleash them online. We have a Master of Information and Data with UC Berkeley. And recently, we have a new venture in undergraduate, which is Semester Online, where you can take a whole semester from a variety of universities, such as UNC or Boston College or Wake Forest, and we just actually added University of Melbourne and College of Trinity from Ireland, so it's international as well. How do we do it? We have a lot of amazing asynchronous content. We self-produce all of our content. We work with universities, content strategists, to make sure that the essence of how they teach is in our online programs as well. As I mentioned, we have a lot of face-to-face learning where there is no back row. I have no clue what half of you are doing in this room. You might be checking email and not listening to me, but when you're like that, you're very clearly face-to-face. We haven't developed virtual babies yet, so if you're, as an example, a nursing student trying to become a midwife, we will place you in a healthcare facility. In this case, you see nurses going through our on-campus intensive, so they fly out to campus and they work with Gus. Gus is a Georgetown University simulator. That's why it's Gus. And it's a freaky doll that can breathe and reacts to anesthesia and things of that nature. And last but not least, our learning management system, what we call an online campus, which is the reason why I'm here. I'm going to talk about Memcache and caching in general, as well as our use of the cloud. The breadth of our technology is pretty wide, because on one side you have to work with university student information systems, and then you have the online campus, then you have to place students and technologies in the middle of it. So the breadth of it is very wide, and anything from content management, CRM, and we're completely cloud-based, and I'm going to cover some of that history with you. But let's start with our online campus. The learning experience is not the pages you read or the tests you take. It's really all the collaborative and social events that happen. If your life is a slideshow, those are the slides you remember. It's the great conversations you had with other students or with faculty members. And that's why we build our online campus to be highly collaborative and highly social. And as you guys know, that could be some spiky data and usage. So let's get into some of the details. So that's one of my latest favorite quotes. So I want to take you through a quick history of our infrastructure and share some of the numbers that we have. In 2008, we started the company. I was there. We had one server under my desk. We had no engineers, no developers. Pretty much just me in the office. Comes 2009, we have a few servers. I hired my first engineer. He's right there. There you go. But I had a brilliant idea to do a co-location in Canada. I thought it was cold, and I would save a bunch of money on cooling. That didn't work out that well. That was actually the architecture in 2009. We didn't realize that not everyone. You remember the FedEx commercial with the counter going up? We started getting a lot of scale. Very quickly realized that we weren't going to stay up, so we kept going down. Pretty much in a meeting, we decided we have AWS is ready. They have our DS. We can build the resilient architecture we want. So we decided over a month of planning to go and build our center. So in 2008, 2010, Amazon is to the rescue. They released our DS, Elastic Load. We implement Memcache. Why? Because, like I said, we started getting scale, all those news feeds for collaborative learning, all those social groups and ability to search came to a crawling stop. So we introduced Memcache first. In 2011, we're now up to 100 instances, only 2 engineers still. We got some redundancy. Amazon S3 started using that as CS. And I think it was in 2012, we're now to 200 instances, only 1 extra engineer. After long planning, we decided to try ElastiCache. And I'm going to read to you guys. We're doing a stage, and this is actually Chris Conlon. He's my vice president of software development. He was the 3rd engineer on that. I'm currently doing a staging build. I had to wait for some database to restore, so for the hell of it, I decided to see if I could easily slip in ElastiCache. Turns out it's very easy. I guess I shouldn't have expected, because Amazon states that it replicates Memcache protocol exactly, but it's still nice when things just fall into place. And I didn't, this is not a fake email. This was done in you can see the date on the right. So there you go. So now we're in ElastiCache. It works. We just kind of works for us, and all of our walls and all of our news feeds and collaborative learning starts floating pretty easily. Small problem, 2012, that's actually my front yard. Sandy comes over, and I don't have a waterfront property. That's actually, Artie, my engineer, tells me that might be bad for us. We should move from Virginia to Oregon. We literally, with probably 4 days of planning, 48 hours, we moved 200 instances over. Yeah, about 200 instances over to Oregon overnight. I can talk about that story because we were losing people were losing power, we were like lose engineers. And we have a small team in Ukraine that watches our servers at night, so we assumed they would be fine. And then they lost their power as well. But we moved, and we're now in Oregon. Brings us to today. We have about 450 instances, only 4 engineers, which is kind of cool. Think about it, my entire team, and we embrace DevOps culture and everything. And that's our architecture. As you can see, we pretty much use everything. Amazon produces. We're huge fans. We're using Amazon Redshift. AWS has been great to us. So if you think about Amazon and AWS are committed to their customers. Our mission as 2U, we're committed to changing your life. And so just to share some of the outcomes I promised to share in the beginning, by having Amazon Web Services and ElastiCache and such, it helps us to not think about infrastructure. It helps us to concentrate on what we do well, which is changing your lives through education. So specifically, our first partner was University of Southern California, Recier School of Education. They had about 68 graduates a year, and their mission statement was to change the face of urban education. And with 68 people a year, that's hard to do. We now have 1,700 graduates, which we're estimating, this is data from Redshift, it's about 3.2 million lives are being impacted from K-12. You have a little over 1,000 students about to graduate. So we're thinking by 2019, there'll be about 12.5 million K-12 students that would be impacted by Master of Arts in Teaching at Recier, right? And these are the sort of outcomes that everyone strives for. And because of AWS commitment to us as a customer and taking our infrastructure out of the way, we're able to concentrate on that. This actually, we're actually global, but it didn't look as good, so I just used the USA map. Each one of those is actually clusters of student learning as of, like, I think 2 weeks ago. And we have some awesome cases. We have a guy on an oil rig 200 miles away from the closest shore who was in Air Force and was involved in Delta II unmanned mission to the moon, and he's getting his MBA, right? We have people, Marines in Afghanistan, who are like sitting on a roof because that's the best place to get Wi-Fi, getting degrees in social work. And this is why I came up, and I was a software engineer, and I've never understood what those guys do in the closet with the servers and everything. And I think with the infrastructure being in Amazon Web Services, it made it easy for us, and it let us do what we do best, and it's changing your lives. Thank you.